In this problem, we're being asked to find the values of x and y given the information here. So we have known two angles. We have parallelism of these two. Okay, this line is parallel to this line segment or side of this triangle. And that's it. And we're being asked to find the values of x and y. So how do you do that? For the value of x, it's fairly simple because picture that these two are parallel lines as they should be. And this line segment, treat it as a transversal. Okay, so if this is a transversal, it creates 45 and x alternate interior angles. All right, so x and 45 degrees are alternate interior angles. And of course, they would be equal. So what does that mean? You can go ahead and safely say x is equal to 45. All right? So that's fairly easy. So x is equal to 45 because these two are alternate interior angles. Now what about the y? There are two ways to solve this. So solve for y. What is the first method? Method 1 is to use the fact that y is a corresponding angle with the 85, right? Because these two are parallel, and y and 85 are the matching corners, right? Y is the same type of corner as the 85. Y is to the right of this transversal, and so is the 85. It's to the right of this transversal, on the same side of the transversal, and they're both above each respective line. Right, these two are parallel lines. Each of these angles is above, right, made above. So these are corresponding angles, and corresponding angles are of course equal. So we're gonna say y and 85 are corresponding angles, and of course these are equal as well. So what does that tell you? That tells you that the y is equal to 85. All right, 85. So now what is the second method? The second method is to use the exterior angle theorem. So using exterior angle theorem. So the exterior angle theorem will tell you that basically the exterior angle in this case is going to be this angle here. This is the exterior angle, x plus y. All right, so the exterior angle, let me underline that, would be the sum of x and y. X plus y. All right, so that would be the exterior angle we drew. So the theorem says that the measure of this angle is the sum of the non-adjacent interior angles. So it's called exterior because this is the triangle in question we're talking about. We know that it has two interior angle measures shown here, 85 and 45, and they're interior because they're inside. However, the exterior angle is outside of this triangle. Right? That's why it's exterior, it's outside. So the theorem says that the sum of these two, well, in this case, this entire exterior angle, it measures the same as the sum of the two non-adjacent interior angles. And non-adjacent because this would be the adjacent. They are not adjacent. They're not supplementary with this angle. Right? This remainder of the angle would be supplementary with the y and x together, but these two are not adjacent, right? They're not sharing the same vertex as the exterior angle, right? They're not sharing this vertex here. They have each their own vertices, this one and that one. So they're not adjacent. All right, so as a result, we can just say y plus x is equal to the sum of 85 and 45. 85 plus 45. And what does that mean? If we add them, look what happens. We know already the x, because we're trying to solve for y here. So we know the x was what? The x was 45, right? The x was 45. We can substitute that in. And that's equal to the sum of 45 and 85. So 85 plus 45. So look what happens. On both sides, we have the same number. 45 and 45s, right? So we can cancel them out, because if you subtract them, both of them will be gone. So as a result, look what happens. Y is left on the left side, and on the right side, you have 85, and that matches exactly the result using the first method that we did, right? So you use two methods to solve for y, the corresponding angles method and the exterior angle theorem method. So I hope this was fun and useful. Thank you so much for watching, and I'll see you in the next video.